Hey everyone, ready for another deep dive? Today we're looking into something that's changing the game in AI, AutoML. That's automated machine learning, by the way. Basically, the idea is to make building machine learning models a whole lot easier, taking out a bunch of the manual work.
Yeah. It's like having an AI assistant that helps you build your AI models. Kind of wild when you think about it.
For sure. And the specific approach we're diving into today is called Sela, which stands for Tree-Search Enhanced LLM Agents. And this is where it gets really cool. Sela actually uses large language models, LLMs for short, like the things that power chatbots and stuff. And it uses those LLMs to become better at building these machine learning models.
It's like almost as if you're teaching an AI to teach itself, right? It's a
Yeah,
pretty wild concept.
absolutely.
Yeah.
So today we're going to try to understand a few things about Sela. First, can it actually do better than the existing methods out there? Second, how does this whole tree search thing actually work? And finally, does this mean that now anyone can build a top-notch machine learning model?
I think you'll be surprised by what we find.
Well, I'm ready to be impressed. But before we jump into all the technical details, can you give us a quick overview of AutoML? Like, what are some of the more traditional ways to do it, and why are LLMs such a game changer in this field?
Sure. So traditional AutoML frameworks, things like AutoWika or AutoSclern, they've been around for a while. They work by following predefined steps, kind of like following a recipe to bake a cake.
Oh, I see. So they have like a set way of doing things, regardless of what the actual machine learning problem is.
Exactly, which can work well for simpler tasks. But imagine you're trying to use a cake recipe to make a complex souffle. It's not going to turn out too well.
Right. You'd probably end up with a very sad flat souffle.
Yeah. And that's where LLMs come in. They add a level of flexibility that just wasn't there before. It's almost like having a human expert with you in the kitchen, someone who can adapt the recipe as they go and suggest creative solutions.
Okay, so LLMs bring that human-like intuition to the process. I like it. Now, let's get to the core of how Scylla works. You mentioned there are three main components. Can you break those down for us?
Yeah, absolutely. The first one is called the insight proposer. And this is where the LLM really shines. Imagine you're brainstorming different ways to solve a problem. The LLM does that, but for machine learning. It analyzes your data and starts suggesting different strategies for each step of the model building process.
So it's like having an AI research assistant helping us figure out the best plan of attack.
Yeah, exactly. Now, once you've got all these different strategies, you need a way to organize them, right? Figure out which ones are actually promising. That's where the search module comes in. This uses something called Monte Carlo Tree Search, MCTS for short. Basically, it helps structure the solutions and efficiently searches for the best path.
MCTS, huh? That sounds kind of complicated. Is it like Scylla is navigating a maze to find the treasure? Trying different paths until it finds the best one?
Yeah, that's a great way to think about it. Like a chess player who considers all their moves. But instead of trying every single one, they use their knowledge and experience to focus on the moves that'll most likely lead them to victory. That's basically what MCTS does for Sela. It helps it make those smart decisions about which paths are worth exploring.
So it's not just randomly trying things out. It's actually learning as it goes,
Yeah.
getting smarter with each step.
Right. And then, once this algorithm figures out the best path, it's time to put that plan into action. And that's where the third component comes in, the experiment executor. This one also uses an LLM, but its job is different. It takes that chosen strategy and translates it into actual code, runs the experiment, and sees how it performs.
So it's like the first LLM is the strategist, the second one is the navigator, and the
Yeah.
third one is the builder, right?
Yeah.
All working together to create this incredible machine learning model.
Exactly. It's this teamwork that makes Esla so unique and potentially so powerful. It's not stuck following a set of rules. It can adapt and explore, much like a human expert would.
And that adaptability is key, especially since the world of data is constantly changing.
Absolutely. Now, the big question is, does all this actually lead to better results?
Right. Let's find out. Hit me with those results. I'm ready to be impressed.
So are you ready to hear how Scylla did in their research?
Definitely. Lay it on me.
All right, so they tested SL out on 20 different data sets. These data sets had a whole mix of machine learning problems. Some were about classifying stuff, some about making predictions, and they were all from well-known sources, like the AutoML benchmark and Kaggle competitions.
Sounds like a pretty good mix of real-world situations.
Yeah, and get this, Esela consistently did better than both traditional AutoML and other methods using LLMs.
Wait, consistently. It beat them all.
Yeah. Head-to-head, Esela had a win rate of 65% to 80% against every other approach. across all 20 datasets.
Yeah, okay. Color me impressed.
Yeah.
But how did they measure performance? Like, what made them say Esla was doing better?
Well, they used a few different metrics to make sure they had the whole picture. So for task, where the goal was to predict a number, like, say, predicting house prices, they used something called root mean squared error,
Mm.
or RMSE.
Right, RMSE. That tells you how far off the model's predictions are from the actual values. So lower RMSE is better.
Exactly. And for tasks where you're classifying things into categories, like figuring out if an email is spam, they used metrics like the F1 score, which basically tells you how well the model is at making those classifications.
Different metrics for different problems make sense. But I also saw they mentioned something called a normalized score in the research. What's that all about?
That's a clever trick they used. They wanted to make sure they were comparing apples to apples, right?
Right.
Because all these different metrics have different scales, so they
Mhm.
needed a way to put everything on the same scale so they could compare fairly.
Oh, I see. So it levels the playing field.
Yeah. The normalized score basically puts all the results on a scale from 0 to 1. Makes it way easier to see which method is really doing better overall.
That's pretty clever. So no matter what the specific metric was, they could use this normalized score to see how Sela stacked up.
Exactly. And based on that normalized score, SLA came out on top pretty much every time. It shows that it's capable of getting better results on a whole range of tasks.
Okay, this is all sounding really promising. But let's play devil's advocate for a second. The paper did mention some limitations of Sela, right? Like, what are some areas for improvement?
Yeah, of course. It's important to remember that Cellar is still pretty new, it's still early days. And one of the main things they're working on is making it more efficient. Right now, if you have a really massive data set, the search process can take a lot of computing power and time.
So it's not quite a plug-and-play solution for every situation yet.
Not quite, but the team behind Sela is working on optimizing the algorithms so it can handle even larger data sets in the future.
Yeah, that makes sense. It's like any new technology. There's always room for improvement. But even with those limitations, this is still a pretty big deal, right?
Absolutely. The fact that Hella can do better than traditional AutoML and other LLM-based methods, it's a huge step forward. It shows that we're getting closer to a future where AI can play a bigger role in helping us build these models, even if we're not experts ourselves.
Yeah, that's really exciting. Now, I wanted to dig a little deeper into Sela's performance. The paper mentioned something called an ablation study. Can you explain what that is and what it tells us about Sela?
Sure, an ablation study is kind of like a scientific experiment where you remove or change different parts of a system to see what happens. Like, how does each part contribute to the overall result? Kind of like taking apart a clock to see how each gear works.
Okay, so they're trying to isolate what makes Sela tick, so to speak.
Yeah, exactly. And one of the most interesting things they found was about the Monte Carlo Tree Search algorithm, the MCTS, the part that guides the exploration, helps it choose the best paths to explore.
Right, the chess player analogy. So what happened when they messed with the MCTS?
Well, they compared a CL using the MCTS to a version where it just randomly sampled insights, basically taking away its ability to strategically navigate that search space.
So it was just wandering around aimlessly.
Pretty much. And the version of Sela with the MCTS consistently did better than the random one.
So having that smart guidance system really makes a difference.
Yeah. It means that SEL's success isn't just about having those powerful LLMs, it's about how they're guided and directed through that smart search process.
Okay, so the MCTS is a key ingredient. But hold on, even the random version of Othello still beat one of the other LLM-based methods. The data interpreter. That's interesting, right?
It is. It means that even without that strategic guidance, SEL is still doing something right. It was still able to outperform a method that relied solely on the LLM to come up with solutions.
So what does that tell us?
It suggests that SL is also really good at structuring the whole search space. It's like giving the LLM a well-organized toolbox and a clear set of instructions, which helps it come up with more meaningful insight.
So it's not just about having a smart AI, it's about giving it the right tools and the right structure.
Exactly. And they also looked at how Sela's performance changed when it had more chances to explore and refine solutions. They call these rollouts. And as you might expect, the more rollouts, the better Sela performed.
So practice makes perfect, even for AI.
Yeah. And that ability to constantly get better is really exciting. It means Sela could become even more powerful over time.
I'm loving this. Now, are we talking about any specific LLMs here, or could Sela work with any of them?
That's a great question, and it's something they looked into as well. So
Yeah.
for the main experiments, they mainly used DeepSeek v2.5, which is an open source LLM. It's known for being really good at coding and cost effective.
Okay, makes sense.
But they also wanted to know if Sela was limited to just this LLM. So they ran some tests with other LLMs as well, like Claude 3.5 Sonnet and GPT-4.
How'd it go?
It went really well. Celia did well with all the LLMs they tried, so it's not tied to any one specific model.
So it's adaptable. It can work with whatever LLM fits your needs.
Exactly.
That's awesome. So whether you're working with a free open source model or a top-of-the-line commercial LLM, SEO should be able to use it to build elective models.
Yeah. And that flexibility is really important because it means SEO can adapt as new LLMs become available.
This is really impressive stuff. But can we go back to those amazing results for a second? Like, were there any standout examples where Sela just blew the competition out of the water?
Yeah, for sure. They used a variety of datasets, each with its own challenges. One that comes to mind is the gesture phase segmentation process dataset. It's all about classifying hand gestures based on sensor data.
Oh, cool. So SEO was learning to read body language.
Pretty much. And it's a tricky problem, but Sela really nailed it. It got a normalized score of 69.2%, which was way ahead of all the other methods. The next best one got 64.4%.
That's a big difference.
Mm-hmm.
Any other examples you want to highlight?
Yeah, there's another one that really stood out, the colleges dataset. This one's about predicting graduation rates for colleges in the U.S. based on things like student-faculty ratio and tuition fees.
So predicting the future success of students based on their school.
Yeah, and ESSL did really well here too. It got a normalized score of 87.8%. This time, it was pretty close to AutoGluon, which is a traditional AutoML system that's known for being good at those kinds of predictions.
Wow, so it was neck and neck with one of the best.
Yeah. But these are just a couple of examples. Across all the data sets, ESSL consistently showed that it could handle different tasks and get great results.
All right, you convinced me that SEO is something special. But we've talked a lot about performance and all the technical details. Let's zoom out a bit and think about the bigger picture. What does SEO's success actually mean? Not just for AI, but for the everyday person.
Right. So if we think about the bigger picture, SLA's success is a sign that we're entering a new era of AutoML, an era where these LLMs aren't just automating stuff, but they're actually pushing the boundaries of what's possible in terms of how well they perform and how flexible they are.
So it's not just a cool tool, it's a sign of what's to come.
Exactly.
But let's talk about something practical. Cost. We mentioned that DeepSeek is supposed to be cost-effective. But using LLMs can get expensive, right?
Yeah.
Especially if you're running a lot of experiments. So how does Sela handle that?
That's a great question. And it's something the researchers thought about too. Remember how we talked about Sela saving its progress at each step, like taking snapshots of its work?
Yeah. Or what?
Well, that's not just about consistency. It also helps keep costs down.
How so?
SLA stores the code it generates at each stage. So if it encounters a similar task later on, it can just reuse that code. It doesn't have to start from scratch every time.
So it's learning to be more efficient, not just in finding the best solutions, but also in how it uses resources.
Exactly. And they actually did a cost analysis, comparing Sela to other LLM-based AutoML methods, and Sela was the most cost-effective.
So it gets amazing results without breaking the bank.
Right.
I like that. Now, can we go back to that case study for a minute, the one in the paper?
Mm-hmm.
I always find it helpful to see a concrete example. So what kind of problem did they focus on in that case study?
They actually focused on the gesture phase segmentation processed dataset, the one with the hand gestures and sensor data.
Oh, yeah, the one where Sela really shined.
Exactly.
Okay, I'm all ears.
All right, so remember how we talked about Sela breaking down each task into different stages?
Yeah, like understanding the data, then comparing it, engineering features, and finally training the model.
Right. This case study focuses on the feature engineering and model training stages.
Okay, so feature engineering, that's all about transforming the raw data into something the AI can actually use, right?
Exactly. It's like taking those raw ingredients and preparing them to be cooked.
I like that analogy.
So in this case, Sela starts by looking at different ways to extract meaningful features from that sensor data. You know, how to represent those hand gestures in a way that the AI can understand.
Okay, so what kind of features did it come up with?
Well, it tried a bunch of things. One approach was to create features that capture how the hand is moving, like the speed and force of the movements, the magnitude of the velocities and accelerations.
So not just where the hand is, but how it's moving.
Right. Another approach was to look at changes in the sensor readings over time. like the difference between consecutive
Oh,
readings.
so like the rhythm and timing of the gestures.
Exactly. And it got even more creative, looking at things like the spatial relationships between different parts of the hand, like the distance between the fingers and the palm.
Wow, it was really analyzing those movements in detail.
Yeah, and this is where the LLM really comes in handy. It can generate so many different feature engineering strategies,
Where
way more than a human could come up with on their own.
That's incredible. But then it has to figure out which of those strategies are actually the best, right?
Exactly. That's where the MCTS comes back in. It helps SEL systematically try out different combinations of features and see how well they perform with different models.
Like a chef experimenting with different ingredients and cooking methods.
Exactly. And in this case, Sela chose a combination of time-based features and a specific type of model called a support vector machine, or SVM. That combination gave it the highest accuracy in classifying those hand gestures.
So it found the perfect recipe, so to speak.
Yeah, and it did all this pretty much on its own. It's a great example of what you can achieve when you combine LLMs with those smart search algorithms.
It really brings the whole concept to life. Seeing how a Sela takes a real problem, breaks it down, and finds the best solution.
It shows how AutoML is becoming more sophisticated. But before we wrap up, let's take a moment to think about what this all means in a bigger
Yeah,
sense.
let's do that. What are the implications of Sela's success? What does it mean for the future of AI? Okay, so we've spent a lot of time digging into Sela, how it works, how well it did in the research, even saw it in action with that case study. But now I want to talk about the so what. Like,
Mm.
what does Sela's success really mean for the future? Not just for AI researchers, but for everyone.
Yeah, that's the big question. And I think Sela has the potential to make AI accessible to way more people.
What do you mean by accessible?
Well, right now, building and using these fancy machine learning models takes a lot of specialized knowledge. But with Sela, imagine a world where you don't need to be an AI expert to use it.
So like small business owners could use it, or researchers in other fields.
Exactly. Think about a small business owner trying to optimize their marketing, or a climate scientist analyzing huge data sets. SL could help them use AI without needing to learn how to code everything themselves.
That would be a game changer.
It would, but we also need to remember that Sela is still a new technology, and there are things to keep in mind as it keeps developing.
Like what?
Well, for one, it relies a lot on those big language models. As those models get even more powerful, we have to make sure we're using them responsibly.
Right, we don't want any unintended consequences.
Exactly. Another thing is transparency. As these models get more complex, it can be hard to understand how they make decisions. And with Sela, where you have an AI building another AI, that becomes even more important.
So we need to be able to understand why Sela makes the choices it does.
Exactly.
Okay, so some things to think about as it develops. But overall, the benefits are pretty amazing.
I think so. We could be on the edge of a whole new era of AI, where it's not just for experts anymore, but something everyone can use.
And that opens up so many possibilities. I'm already imagining Sela being used in education, healthcare, even art.
The possibilities are endless. The researchers mentioned software engineering, science, robotics, even helping doctors diagnose diseases or teachers personalize lessons.
If AI can learn to build better AI, who knows what else it could learn to do? It's both exciting and a little bit scary, to be honest.
That's the thrill of being at the forefront of this stuff. We're constantly pushing the limits. There are challenges, but the potential is huge.
That's a great way to put it. Well, I think that's a perfect place to wrap things up. We've taken a deep dive into Sela today, learned about how it works, what it can do, and what it might mean for the future. And this is just the beginning. I'm excited to see what happens next with Sela.
Me too. Thanks for joining us on this exploration.
And thank you all for listening to The Deep Dive. We'll be back with more fascinating topics and groundbreaking research. Until then, keep exploring, keep asking questions, and keep pushing the boundaries of what's possible.